Okay, hello everybody. It's time to approach this. I've had some technical issues. Hopefully this is fine. I've had some technical issues last night and I had to make a full factory new reinstall of Windows and everything on the computer. As you can see, I'm still not up to date with everything, but I have most of the needed software installed. So what we'll be approaching today is part of the e-NABLE collaborative design teamwork, and we need to figure out a new single finger design. Now the last one that I made was a push-pull design that was sadly optimized for wires, and as you can see it's surprisingly simple. However, I did make it way too big. And if we check the joint movement, it was actually surprisingly good. The issue is that when it's straight, the cable tends to bend down here, so it wouldn't get quite the same movement on going up, on extending a finger, as you would get on closing the finger. So that's the issue that we're gonna be dealing with today. Now I'm not 100% certain how to approach this. I have some ideas, but I have no idea how the end product will look after all, and I also have no idea if we actually will manage to complete this challenge in the 1 hour time frame. But we'll see. The hand that we're basing the filament push-pull mechanics is the Osprey hand. I'm gonna find it in the devices, just a second. I can't find it in the devices. Oh, there it is. Right, so for those of you that don't know it, this is the Osprey hand and it functions based on filaments. And the part that we really care about is inside the fingers. Now, according to John, the wires go fairly straightforward inside the fingers, so I don't have Blender installed, but I suppose we don't technically need it. We can just download the STL files. And we can check them out in Prusa Slicer directly. I'm gonna be downloading all the files. Oh dear God, that's quite a lot of Osprey files. Okay, so now we just need to figure out which one of these is the bloody finger. Yeah, that's gonna be harder than I expected. So the question is, if I try to add something from the Osprey right like this, will it slice? Yes, it does slice, so we can figure out the inside geometry. Okay, now we just need to figure out which. So we have proximals and okay, so the proximal is fairly straightforward. I don't quite understand why there is a hole up here, but I guess we'll see in a second. And we need the distals. Wrist pin remover. Let's go with palm right as well. Oh, this is a full assembly. Nice. We can definitely use the full assembly. Right, so it doesn't let us do anything, so we're just gonna rotate and cut it. We don't need to be precise or fancy right here. We're gonna be keeping just the upper part, then we can rotate it once again like so, and now I can slice it to figure out how the internal design looks. Okay, let's see. So we have the same pins that we had on the Phoenix. For some reason we have a hole that goes all the way through the model. I'm guessing that's gonna be the extensor. Yeah, because it does seem to be connecting here, which is a weird choice because technically this is a push-pull, or at least this is supposed to be a push-pull mechanism. Nothing to worry about. Let me check the chat. Nothing's going on in the chat, that's perfect. Okay, so if we slice it up, let's figure out where the bottom channel is, because I've been advised to make the bottom channel as straight as possible. So we can see the hole right here for the bottom channel. It goes all the way down. Okay, that's not really a major issue. The angle at which that comes, granted, that's still, yeah, no, that's not gonna budge because that's 45 degrees. And for the front one, so for the front one we have another hole right here which goes down, underneath and upwards. Okay, so that's the movement of the Osprey hand. How should we be dealing with this? Oh, right, I remember. So we're gonna make a new design from scratch. Of course we are. And let's see what we had in the sketch for this one. Okay, so nothing major. The way I'm gonna be approaching this is I'm gonna make one that doesn't have any of these little holes, because those need to be parametric. I'm just gonna make a normal one at first to check the functionality, and then we can have another go at creating these small spaces, because that's gonna be a little bit more complicated. So let's say this is one joint. We're gonna be making this as 20 millimeters. I believe on the sketches it was 40 millimeters, right? Yeah, so we can definitely make it smaller. We can make it down to 20 millimeters. Actually, let's keep it 40. It's gonna be pretty much the same size. I shouldn't have closed it. Oh, there we go. We don't need the sketch right there. So let's firstly create the interference pattern between the blocks, and then we can figure out where the channel should be. So in order to get the interference pattern down, actually it's easier to start with a giant rectangle, and we're gonna be using constraints to connect to the circle to make sure that this is the outside dimension as well as the inside. This part right here is gonna be the part that's connected to the hand. Let's make another circle of 30. We're gonna be connecting it to the first circle, and as long as the lines are blue, that means you can move them around. If you start constraining them, they're gonna be turning black, which means you cannot move them around. However, don't be tricked, it doesn't necessarily mean they are fully constrained. However, if we go like this, let's say a good 50. I guess we can do more, let's do 70. There you go, now the circle is fully constrained as well. So that can't move, this can't move, that's perfectly fine. And now we can have the distal right here. If we stop the analysis, as you can see, it's not a particularly complicated design from this point of view. However, we do need this weird hole down here. So... actually, do we? Yeah, not right now, we don't. And in order to get some pins in here, we're gonna be making small holes that are about 3 millimeters wide. Okay, now let's give off some final dimensions. This is gonna be 40. Well, it said 40, there you go. And this is gonna be another 40. And let's extrude this bad boy, see what happens. So we have to do the outsides inside, and then the inside piece will be having the two joints. So the first thing that we're going to be doing is the inside piece, symmetric, and let's say it's going to be 2 millimeters in each. Well, let's give it a little bit more, let's say 5 millimeters. That looks about right. Now we still need the old sketch, and we're going to be extruding these two parts as symmetric with again 5 millimeters each. And if we don't make this body invisible, they're going to be trying to connect, so we can always select the operation down here to be new body. Okay, we can now make the three bodies invisible, and we're gonna be making new bodies out of this. Now we already have something in here that's 5 millimeters, so we're gonna be offsetting this by 5 millimeters and then extruding them another 10. There you go, and the same thing on the other side. So offset -5, extrude -10, and now we have all the pieces of the puzzle together. Okay, not all of them. We still need these two pieces. So we're gonna have the same offset of 5 millimeters with a distance of 10. Remember to keep it as a new body. And then the same on the other side, just with negative numbers. Right, now let's combine all of them to form our shapes. We're gonna make the sketch invisible, and let's start having fun. 1, 2, 3, and 1, 2, 3, and the middle piece, which is technically the proximal because this is going to be part of the hand. And there you have it. And if we go with an inspect section analysis, actually let's have the section analysis directly on the... Can I? No, I cannot. Really? There you go. A pro tip is to always make the bodies that are in your way, make them invisible. Don't even care about them. Okay, so this is not particularly visible to what we've done, but if we move this around a little bit, as you can see, the insides are on the right side. What we can do, there we go. So this makes much more sense, right? So that's gonna be palm, this is gonna be distal. Click and then click again to rename your parts. If you have more than 3 parts, it's always a good idea to rename them. And this is gonna be proximal. Alright, let me check the stream. No questions anywhere, that's perfect. Right, and let's see how this looks. Yep, that looks fairly okay. Just one teeny tiny issue. If we try to rotate this, it's gonna be hitting on the bottom on this curvature. So if we go back into the sketch, we need a line that goes straight down. With this one we can press X to be invisible, and that's called the construction line. L to create new lines, click on the line, press X to make it invisible. That line is still useful because it marks this specific point as being horizontal from the center. We finished the sketch and now we need to modify this particular extrusion. And there we go, now we have space on the inside. And just to check that everything is going alright, we're gonna be turning these 3 parts into components, which doesn't really matter what it actually does, but for our intents and purposes, now we can make joints between them. Now I'm gonna select the palm, right click and ground, which means that nothing can move this object. And now when I press J to build a joint, I can select an axis over here, an axis and a spot over here, select motion, go to revolute, and as you can see now it spins. That's nice, that's very useful. And we can actually use that to simulate how things are actually moving around in real life. I'll be showing you that in a second. Now, when we try to move, in order to connect these 2 joints, select both of them, right click, and it's not in here. It's going to be in assemble, motion, no, assemble, motion link, and then you select the 2 joints. They seem to be moving both at the same time, so that's perfectly fine. And we have the following issue. If we drive this, as you can see, it starts getting this issue right here, so we need to cut this down on both sides. The way to do that is go back into the sketch, make these fancy little lines right here, and now we have to modify it in our original extrusions. Now every time I edit the first sketch, I'm actually going all the way down here, so when I go and edit some of the old things, for example this one, I'm after the sketch has been done, so I can already see the lines. We are technically editing in the past, which as you can imagine is crazy useful. Okay, so that's the middle part, we don't want that. However, this one is not the middle part, so we can deselect these. And I believe it was this one. Deselect that specific region, and there you go, now it should be able to move. So if we drive the joint, yeah, it makes much more sense. Now our joint is designed to only go 90 degrees, so we're gonna go with edit joint limits, minimum, maximum, and the rest of 0, and the maximum is gonna be 90 degrees, which is gonna be straight down. Now because we have a motion link, this is gonna be moving both of them at the same time. Yeah, that's a bit weird, but that's perfectly fine. One advantage of simulating with Fusion 360 is that you can animate the joint, or you can animate the entire model, and that's gonna animate all of the mechanics as well. Now this doesn't include the physics, so things might go through each other, but it does include all the kinematic chains, so it's still a very useful feature. Now we can also enable physics by enabling all contact, and now we can animate the model again, and as you can see, it's still just fine. And to test the physics, we can have, let's say the limit right here is 180 degrees, which is not possible because it will crash into the palm side of the model. Now if we animate the model, as you can see, it gets stuck right here because it figures out I'm not supposed to go there, there is something in my way, which is very, very useful. Right, so that's how you basically animate it. Let's make a channel and see how it looks. We're gonna be making the channel in the first sketch as well. So let's say the channel, it has to come from the top, and let's say it meets up on this line. So we're gonna have a line like this. Oh, and this is a very nice trick to build channels. You can just sketch them as a line, and that's gonna be good enough to get I only want 45 degrees. Something is weird. If you want to sketch a slot into something, 135, it's gonna be more than enough to just sketch a single line. I don't know why there is a point right there. That's weird. Anyway, we're gonna have the distance, this distance, let's say it's gonna be 3 millimeters. And this is still not parametric, but we don't really care that this is blue and we can move it around. It's just a slot. So in order to make a slot out of that, we're gonna go with create pipe, and now we need the bodies to be slightly invisible and the sketch be visible. So once I hover over this, it's gonna be having a chain selection, which might select this line or might not. I prefer to not use the chain selection and select the line myself. Now by default this is gonna make a round slot, but we want a square slot simply because this will print much better. Now when we re-enable these, the slot will actually be an extraction. Another pro tip is to make this line slightly longer, because otherwise you're gonna get leftovers like this thing. So we're gonna go back into sketch 1 and make this thing ever so slightly longer, and it makes it parallel to the first one on its own, and make this thing slightly longer again. There we go. If you know how to play with Fusion, it's gonna try to make all the lines parallel, and it's really it's a really useful helper tool once you get the hang of what it actually wants to do. There we go. So now we have the slots just fine. Okay, let's say section size is 2 millimeters. Okay, the operation is a cut, let's say okay. And we're gonna make the sketch invisible, and let's see how the slot looks. Now to check the slot we can use the section view. There you go. So now the section view really becomes important. So this is where the filament is supposed to stay as long as the finger is straight. Let's right click on it, drive the joint and drive it all the way to 90 degrees. Now that's not very useful, is it? Because now the filament is supposed to come over here and teleport all the way up here. So how do we figure out where this spot is so we can delete this entire chunk of mass? And that's pretty much why this model does this. See, this is completely open, which personally I don't really like, but I suppose that's up to everybody's preferences. So there are two ways to do this. We can make a sketch and destroy the flooring of this, or we can make a sketch on the first sketch, which is the version that I like. Let's see, and we're gonna be extruding this sideways. So that's the middle of it. This is just a simple line. 1, 2. Oh, actually we don't need this. So we're gonna have them constrain the symmetry. So we're gonna select the first one, the second line, and then the symmetry line. And now they are symmetric according to the symmetry line. And let's say this is gonna be 10. Okay, that looks fair enough. And now if we reactivate the sketch, we can hit E for extrude, and we can take this this chunk of mass out. That doesn't look parallel. Is it just my oh yeah, it's just my imagination, because this doesn't look parallel. I guess it's something to do with anti-aliasing. Anyway, if you're not sure that something is parallel, scroll in. It's not a bug, it just looks weird. So we're gonna go with symmetric, and we're gonna be making the sketch invisible and using the walls of our slot right there. Okay, so let's see how it looks without the section view. Okay, this is decent. And now when we rotate the joint fully, this is how it's gonna look. That's actually not too bad, because the filament has more than enough space to go in here and all the way down here. I would have liked it to have 45 degrees over here as well, but that's not really all that much of an issue. Now we do have an issue with the minimum radius of a bend. Now basically, because the filament is solid, we don't want to try to pinch it too much, because it will break. And even if it doesn't break, it's gonna get caught on in the mechanism and create a lot of friction, which is really bad for the user. I'll be right back. And I'm back. And create a, which is really. Let's put a little bit more music in here. There you go. Hopefully you can still hear me alright. Alright, so how do we deal with the filament not being able to pinch? Basically, if we keep it like this, let's say we're capturing the... actually no. If we go in the first sketch, so right here, it's going to be trying to pinch between this angle and the slot that comes downwards right here. For the ease of showcasing this, I'm gonna be creating a new sketch. I like working on a very small number of sketches, but it does tend to get a little bit finicky when you work too much with a single sketch. So technically we have this part and this part, and our line comes in right here and goes all the way down. Now let's make a bit of symmetry, so between this one and this one, and that's gonna center this line in the middle, and we're gonna do the same over here. Whoops, let's try that again. 1, 2, 3, there we go. So now that's in the middle, and that point is going to be fixed because it's the intersection of two very precisely placed lines. So technically we know that the filament is 2 millimeters wide, or rather 1.75. Question is, what is the radius of this bend? Technically, it has to come straight and bend over here completely straight, but that would only be the case if it was something like this. So if the case was like this, then the bend would be completely straight. However, it's not. We have a little bit of play right here. Basically, in real life, the curvature is going to be something like this, right? So let's say we have a circle like this, which is going to be tangent to both of our lines. And that's pretty much it. As you can see, you can't go quite like this. So it has to be tangent here, where it actually escapes. There we go, that's roughly right. Because if it's tangent before that, it's gonna be trying to crash into this corner. Now here we don't have many issues because it's gonna be tangent to the middle of the slot. Question is, what is the radius of this? So we hit D for dimension, and turns out it's about 18 millimeters, which is actually not bad at all. Okay, so in this case it's not gonna be pinching as long as we have this part low enough. Theoretically, according to our measurements, we could have this rectangle to be going all the way to the intersection point right here. So it would be going all the way up here, and the line would still have enough space to move. And we're probably going to go with that, so with the upper limits, simply because otherwise the line will get exposed, and we don't want the line to be exposed too much. We're gonna need to make this actually, do we need a smaller diameter? I don't think we technically do. this one they used... Oh dear, that's quite a loud music, I just realized. That's a bit better. And let's change the mix altogether. Right, so on the Osprey design I can see they went with the radius to be as big as possible. Okay, that's fine. Oh, we only have 15 minutes left, so I better start hurrying it up. We're gonna be finishing this sketch as we just used it to create the minimum radius. Now if we go with drive joint and make it straight again, the minimum radius is gonna be another very similar thing. Actually we can use the same lines over here, and we're gonna have straight line and then another line over here. Make it fully symmetric and make this one fully symmetric as well, and make our circle to figure out where the limits of it are. Okay, so the circle right here needs to have a minimum distance to this point of at the very least half the distance. So we will need to fillet this particular point just to make sure that we don't get any friction in there. This is not the most constrained design. However, this is still just a prototype, so on later iterations we're gonna get more precise with our geometry. As for this side, technically we don't care about where these points are, we just care that the distance between this point and the circle, so the circle right here, let's say is 10, let's say it's 10. The distance between these two needs to be... I don't actually know how to make this right. Oh, I know. What if we have a line to the center, which is just gonna be construction. We have another line all the way up here, which is gonna be construction again, and that's the giant radius, and now we can measure this part to be 0.85. The issue with that being that this is a little bit too thin. Okay, so those are the major issues with this design, and I guess we can make that bigger. There we go, and if we move the entire thing down here, yep, that's where things start to get a little bit sketchy, because we need this distance to be greater than half of the diameter of the filament. But since we are dealing with 3D printing, and most of the people printing this won't have very precise printing capabilities, care that much. Now, while on the front the line is very unlikely to bulge in here. The line is still very likely with the 45 degrees in here to be bulging. So what I think we should be doing is going to the first sketch, and instead of having these, we're gonna have a giant curve. So let's say a 3-point arc, something like this that is tangent to this one. So this is actually going to come out straight. Yep, and it's throwing us an error on the pipe because now we need to select the new thing. And it doesn't like it. Delete it, and we're gonna make another pipe. Make the sketch visible and go all the way to the front. There we go. However, it didn't cut through this one. Oh, it did cut through it. Still throwing us... Oh yeah, it doesn't like the two new sketches. But we don't need those two new sketches. So if we go like this, we can delete all the features after the history marker. Question is, why doesn't it like the pipe? Body creation failed. Actually, I have no idea what's going on right here. So I'm gonna delete both of these and create a new pipe from scratch. There is probably some issue that I'm not seeing, but it's fine. Section size is gonna be 2, and the operation is gonna be a cut. Still doesn't like the operation. Could it be because of this line? Okay, let's try again. We're gonna make another pipe just with this one. That's just fine. And then another set of pipes with these two. Okay, now it doesn't have an issue. It's probably because this is a curve and this is a straight line, I suppose. Oh yeah, because we can see the sketch, we can also edit the sketch while not being in it. So we can definitely do this. Right. So that looks about right, and this way I don't think we're gonna have many issues. However, now that it's not going to be bulging in here, we also need to remove these parts. Symmetric and all the way to the walls. Now the issue that we're gonna have is if we drive the joint 90 degrees, that's quite an issue, as you can see. It's not gonna bulge, it's probably never gonna get out of there, because it's gonna try to bulge towards the center, which we already have material there, so it won't escape. However, the minimum radius of the bend right here is quite an issue. So let's make a sketch right here to figure out what the minimum bend is depending upon. So if we project this, we're gonna have a 3-point arc that's starting from over here. That's gonna be a construction. That's gonna be a construction. Oh god, I cannot snipe the right position. 3-point arc in the middle, and it has to be the middle of this one. And it doesn't want to take it. Okay, then we're gonna make a square. It doesn't want to make the square either. What is this? Oh, it's because that's not a line. Okay, that makes more sense. So, do I have access to the middle of this? No, I do not. This we mark as construction. And now we should be able to make our desired 3-point arc. So, middle, middle. Well, technically the circle is going to be standing right here. There we go. So that's the minimum radius that we're going to be having, which is only 6 millimeters. Now, in real life, 6 millimeters is very small. Like, it's only double the diameter. And this is the diameter of the circle, so the radius of the bend is incredibly small. So, how do we deal with this? Well, there are two ways that I can think of at the very least. Number one is get this distance right here, from left to right, get this one to be bigger. Because technically the radius over here is going to be this one plus half the width of the channel. Now the channel is always going to be about 3 or 4 millimeters, so that's going to be 2 millimeters from the get-go, plus this this part right here. So let's say a decent enough curvature would be what's a decent enough curvature? Let's say it's gonna be a radius of 10 millimeters, so that's gonna be a 2 centimeter bend, which is still very small, but it's a heck of a lot bigger than this. So if we want a radius of 10 millimeters, 2 millimeters are coming off of here, and then we need another 8 millimeters in here, which is quite a lot. That's not particularly good, because if we're gonna make this like that, then the diameter is going to be 20 millimeters, and the slot is going to end up in the middle of the finger, which is less than ideal. Solution number 2 would be to have this slot slightly angled, so the middle slot would be going up and over. Okay, let's see how solution number 2 would be looking. So instead of having this line, whoops, maybe not that, we would be having believe it's going in right here. Huh, I completely forgot. So this is going in a little bit after this. Okay. So it's gonna be somewhere over here. And then we're gonna have the two mirror around this line. And to get this a little bit backwards, let's say right here, we're gonna create another slot just to see how it looks for these two lines. Right, so it's not a big deal, it's just another slot. And technically, if we have the upper one, we don't need the bottom one. And when it does move, we can make the first sketch invisible. Within this sketch, it's actually not very useful. That's a bit disappointing, because this slot cannot go higher than this. This is already quite a bit of a bend. It can't go higher because it would create too much friction. Well, if you can't modify the slot, you're better off modifying the angle that's coming in over here. So I'm gonna go with finish sketch and go where we first made the pipes, make the sketch visible, go into the sketch and delete this constraint, and we're gonna make the curve to be much nicer. Maybe something like this. Okay, the path is not gonna be perfect, but that's perfectly fine. So yeah, now it's much more feasible. So if we delete this circle and we have another circle of about 20 millimeters, yeah, that's much more doable, and we don't even need this one. So I suppose this can still be about 30 degrees when it leaves. And because it's coming upwards, so it's coming from the top, it would be coming at the best case scenario 45 degrees. So we can go with the top nearly straight down, and then we can have a curvature that orients it all the way down to about 30 degrees. And we can have the same alignment over here as well. Oh, already it's 1 hour without much progress, but that's perfectly fine. Not every day is a productive one. Okay, so we're gonna make a quick design of how this will look in the end. Okay, bear with me, this is gonna be a little bit faster. So we have the two circles, that's 40 millimeters in diameter. Let's say this is 70. That's gonna be 40. This one is gonna be 40 again. Now we want a couple of things. Number one, we don't want that interference right here. So we're actually going to be offsetting the outer circle by about 2 millimeters. This is a construction line. We need this to go all the way down on both sides. Okay, that's snipping to the right point. And now for the channel itself, let's say we have a line. The line is never going to go past this point, so we can have the line just over here, because when this is rotated, this point is going to be right here. Let's say this distance is going to be 4 millimeters, which is quite a bit, but remember this is the middle of the line. Now we have a point right here. This is going to be 160 degrees, no, 150 degrees, so that the bottom line is 30 degrees. And the distance between this one and this one is going to be another 40. Whoops, sorry, that's supposed to be 4. Okay, now we're gonna have the 3-point arc right here. Delete the weird tangent, and we're gonna set our tangent manually just so that we know it's the right one. And now we can play with this as much as we want. Okay, let's say it's something like this. Now according to this one, having 30 degrees here would be just fine as well. So in order to move from one measurement to the next, actually let me showcase that. So in order to move from the blue one to the other one, to the degrees, you just have to press tab. And there you go. And then press tab again to have it fixed. And now we can play around with the dimension without tinkering with the degrees as well. And this dimension is going to be 4. We also need this part to be slightly longer. And we also need this part to be slightly longer as well, because this will need to cut through properly. Okay, we also need points in the here. Let's say it's gonna be 3 millimeter holes for the pins. Okay, what other spaces do we need? So we have a little bit of interference space right there. We're gonna have plenty of space here. We will need some space between these parts, because 3D printers are not perfect, at least not in the hands of normal makers. This one needs to be 40. I said 40. There you go. That's quite an issue. The point didn't, whoops. There you go. Now it's properly connected. I'm going down the line, up the line, and Fusion will know that I want to make something that's parallel. Okay. Well, let's extrude everything. We're gonna start with the palm. So the middle side of it is gonna be pretty much empty. It could could be making that to be a little bit less annoying, but that's not technically needed for the mechanics to work. So we're gonna have 5 by 5 in the middle. We need to keep this sketch alive. Make the first body invisible. And then this is going to be the exterior, which is going to be offset by 5 millimeters with a distance of 10. Same thing on the other side. So offset of -5 with -10. We're gonna make this invisible, and now we're gonna deal with the middle one, which is going to be... Oh, we are missing some lines after all. So the way the middle circle is going to connect to this one, that's actually quite a curious case, because this would need to go all the way to over here. And all the way to over here as well. So this is going to connect over here, and here on the top we're gonna make a construction line that's vertical. We don't need this to be quite as high. And then from this side we're gonna be connecting it straight over like this. And same thing on the other side as well. Okay, finish the sketch. And what did I do wrong? Oh yeah, this is not supposed to be like that. This is supposed to be vertical. Now we didn't make a stopper, so as you can see right here, this does have a stopper right there, which is basically just two plates facing each other. However, we don't have one, which is quite a bit of an issue. But testing can be easily done without one as well, so this is fine. Okay, so we're now at the middle part, which is gonna be this one's. Yeah, actually pretty much it. And this is gonna be symmetric. However, this is not gonna be 4.5. This is actually going to be with an offset. Now we're gonna hit modify, change parameters, and create an offset right here, which is going to be off, and let's say it's gonna be 0.4 millimeters. Yeah, 0.4 millimeters of friction is quite enough. So if we go into sketch 1, this one needs to be off times 2, and this one needs to be offset times 2 as well, because that is simply the offset for the rotation. And now when we extrude all of this, we're gonna go with symmetric and 5 minus offset. What that does is going to create a very, very small offset right there. Right. Now we're gonna go with extrude again. just this part, which, since the interior is solid, we can make it symmetric, and that's gonna be 10 plus 5, that's gonna be 15 in each direction. There we go. Check with the other body. That's... oh yeah, this needs to be offsetted in the other way. So when we did this, we don't need to use this part, nor do we need this part. Yeah, we need a straight down line right here as well. Why is this blue? Okay, we're gonna make a full line. So annoying. Okay, so when we're doing this side, we technically don't need to extrude. This side as well. And with that in mind, we actually need to go a level further. So from here we're gonna go all the way to here, simply because that's where that part is connecting. Okay, let's try again. So on this side we're extruding everything but 1, 2 and 3. That doesn't seem right. Why don't we have the same thing? Oh, I'm stupid. Okay, so it turns out this one needs to be negative. Well, apparently I can't have it negative. However, I can drag this away, and now I have the negative side of it. And I don't know what happened with this line, but I'm gonna delete it. So we're gonna do the same on the other side. Make it wider, have the distance between them 2 times offset, and let's see how this goes. Okay, so things are not looking pretty, but we can fix that. So let's see, where did things started going wrong? So on this side, oh, actually they started going wrong right here, because we don't need this side. However, we should have another line right there. Okay, that makes sense. We're a bit in a rush and we're skipping some logic steps, but this is gonna be fine. Okay, so this one doesn't need this offset. Then the second one is fine. Then we have the third one, and the third one is less fine. We don't need it to cover these sides. Okay, it looks alright, and we need a hole in the center. Okay, so that's the first piece. Then we have the second piece, which shouldn't be touching, and it's not. Isn't that nice how things turn out alright? However, we have to figure out what's up with that hole. There we go, that's much better. This is not supposed to go all the way up. Oh dear, That's supposed to have it all the way there. We need this hole right here, and we technically don't actually need any of this, because it's just going to be a channel through the middle. Okay. And now we need to make the size of it, which is gonna be pretty much just this, surprisingly enough. So this is gonna be join, symmetric, and it's gonna be 15. That's supposed to be symmetric, there we go. And check it with the other. That looks alright. However, we do need that line to be straight down, so we're gonna go into the sketch again and make this new set of lines. Now when we extrude it, we can remove these parts. So now they shouldn't be colliding between each other. And the last part is gonna be fairly similar to the first one. Actually, we can leave the first one be. Something like this. We don't need the middle part. Yeah, I guess this is about it. Symmetric. This is gonna be 5. Yeah, this looks about right. So that's gonna be an offset of 5 with a distance of 10. And that's connecting to body 3. And pretty much the same thing over here. So we're gonna go with offset -5, -10. That's connecting nicely. And there you have it. We have offsets everywhere, and we have parametric offsets. And the importance of parametric offsets comes into play right here, because now I can just modify this value and I can go with 0.6, and that's just gonna make the offset bigger everywhere. Okay, we're still gonna play with 0.4, and now we just need the slots. Yeah, that doesn't look very nice, and I don't know why. So I believe it was this one. Nope, it's not. Oh yeah, no, it is this one. However, no. This one? Oh yeah, there we go. So it's all nice and straight. I'm gonna make section analysis, which is gonna be straight through the middle. And we're gonna create the final pipe. So the final pipe is gonna be, let's say, 3 millimeters, just in case. And another pipe for all the way through. Ooh, that's quite a bit of an issue. We're gonna go into sketch, solve this issue. And now we can make the second pipe. So that's okay. Something broke. When something doesn't work quite the way you like it, it's usually better off to just hit ESC and restart the entire operation. not again. So that's the pipe, and we need to connect these two somehow. We can probably do that just by going like this. So now when we go on the second pipe, we can also connect this part. There we go, that looks alright. Okay, we're gonna make components out of them, name them, and test if this actually works. So this is gonna be proximal, and this is going to be distal. Oh wow, the music is quite loud today, I don't know why. Let me turn it down. Then again, that's why I need viewers for, so that people can tell me if the music is too loud. Right. We're missing a hole. Why are we missing a hole? So it's probably this one. Oh yeah. There we go. We have holes all the way through. We can cancel the analysis for now. Palm, proximal, distal. And let's start making joints. Now, in order, if we make joints normally, they will try to cancel out the offset. So we're gonna press Shift J for us built joint, and we're just going to have to select the bodies themselves. So body, slave body and master body, and the joint is going to be revolute. And now it's asking me to select an axis. There we go. Shift J, slave, master, and this is going to be the axis. And we have the joints right here. Select both of them, assemble motion link. That's quite alright, not the correct direction, but that's perfectly fine. And since it's not the correct direction, this is gonna be -90, and the rest position is going to be 0. Okay, let's animate the model. This looks alright. And let's see in the section view, can we still animate the model? Right click, animate the model. It's not perfect, not by a long shot, but it does look like it's feasible. So let's get it stuck. Whoops. Let's get it stuck at 90 degrees. Yeah, this looks like a doable bend. And there is something that we haven't done today, and I should be ashamed of myself, which is saving this entire thing. So push, pull, always make your part names really obvious. Push, pull, Osprey like parametric offset. Okay, so this is technically push-pull optimized number 3, as you can see right here. There you go. And I'm still gonna save this one just for the laughs. This is gonna be push-pull tester number 3 Osprey-like. Because it's better off to have those tests saved than try to figure out later on Word if you have any testing pieces that you can use. Okay, it's not gonna be perfect, but the chances of it making a giant bulge over here, I think, are lower. Just to make sure, I wanna... There we go, let's go with something like this. and let's make this a little bit higher, so 160 degrees. There we go. So that's only going to be about 20 degrees. So now the chances that it will bulge and get outside over here are much smaller. Hopefully this is gonna be alright. But that should be pretty much it. Thanks for dropping by and watching, and I will be... Whoops, that's not what I wanted to do. So thanks for watching, and I will see you tomorrow. For tomorrow I have no idea what time we will actually be streaming. Probably sometime later in the day, something like 12 CDT. But we'll see. It will be announced on the